Good
Good morning,
afternoon.
everybody.
Welcome
we
to
got Billy
APA's
here.
monthly webinar series. My name is Biocides, Standards and Codes Administrator for APA. Just a couple of housekeeping items before we get started. This webinar is being recorded. The recording will be posted to our website later this afternoon. You will receive a follow-up email tomorrow with a link to the web page where all webinar recordings are housed, as well as a link to our upcoming webinars. We have webinars planned out through December, and many are open for registration. All attendees are in listen-only mode. Please type your questions in the chat box, and they will be answered in the order they are received during the Q&A session at the end of the presentation. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by the presenter. AIA and professional continuing education credits are being offered. Please send me an email at Billie, B-I-L-L-I-E, @apa.org to request a certificate if you did not indicate you wanted one when you registered. Also, if you have more than one person attending this session from a central location, please send me an email so everyone gets credit for attending. At this time, it's my pleasure to turn this over to Chris Kopak, who will be your moderator today. Chris, take it away.
Well, thank you, Billy. We appreciate that. And as always, the ability of our business partners to give back to our members, we sure appreciate that. So Chris Kopak, Assistant Vice President of Facilities at the University of Arizona, past president of our great association, APA. In our continuous effort to give back to our members, we have Darren Foyt from Belfour, over 30 years of experience in the industry. What appropriate time to be talking about water damage principles and recovery as we're in the middle of the monsoon rains, hurricanes in some areas. Hope you're all safe there in Florida. But Darren, we sure appreciate Belfour. We appreciate you taking time to share your knowledge. And as Billy mentioned too, if you have questions, go ahead and type those in, and we'll be about 45 minutes presentation, about 10, 15 minutes of questions. And so with that said, Darren, take it away. We sure appreciate you sharing your knowledge with our members.
It's great to be with you, Billy and Chris. Thanks so much for the invitation. Appreciate those who have taken time out of their schedules to be with us today, and hope you get what you're looking for out of today's presentation. Again, I'm Darren Foyt with Belfour. This is the presentation today is a very, very small snapshot of the IICRC 3-day water damage restoration certification. It's the training that goes out to people in the restoration industry, insurance adjusters, facility managers. This is really what it is for the industry. So that's what we go through today. We've already had a couple of really good questions come in, and look forward to getting to those a little bit later on. Again, on a housekeeping note, this slide is not my slide. It's required for the AIA, but it's very important information. Just talks about the credits will be earned after this is submitted by Billy after the conclusion of this. And you'll notice over on the right-hand side here that they state that they're not promoting or endorsing what I say today. I've been invited as a guest to share some information, but this is not their information. So a couple more slides that they like to have up are a course description today. This is an overview of the ANSI IICRC S500. It's the standard for professional water damage restoration. And we're going to cover, among other things today, changes to the current S500 version. We're currently on the 4th edition. We're going to talk about the category of water damage, which is critical, especially when you're looking at some of the flooding that comes in. And what this refers to is the potential level of contamination. Kind of the non-technical term is the ick factor, what's going on in the water and how that can affect human health, and also our contents and materials that are affected by that. We're going to talk about class of loss, and that talks about what's wet and how wet it is, and the potential rate of evaporation or water coming off those materials, and how critical that is toward proper sizing of the equipment on a job so that we dry it properly and within balance. And we're going to talk about when the job is complete, how we set drying goals, how we use meters to both locate and detect moisture initially, as well as to make sure that everything is dry at the completion of the job. The IICRC, the Institute of Inspection, Cleaning, and Restoration Certification, and their mission is to establish and advance globally recognized standards and certifications for the inspection, cleaning, restoration, and installation industries. So we'll talk about some of those certifications today. We're talking primarily today about the S500. This is the industry standard. There's also the S520, which is a standard for mold. There's the S540, which is a standard for trauma and crime scene cleanup. The S500 for fire and smoke damage is currently being developed. The S900 for cleanup of illicit drugs is currently under development. So this is a certifying body and a standards writing organization. The S500, written by volunteers from the public, private, and institutional sector. So you've got restoration contractors, insurance adjusters, chemical manufacturers, equipment manufacturers, attorneys, all these types of people that are involved in the industry who got together to put these standards in place. And there's just a huge amount of volunteer time and effort and energy that goes into this process to have the procedures to how to identify moisture, determine the contamination levels of moisture, properly dry the moisture out of a building and return a building to what we call a pre-loss or pre-remediation condition. The first version of the S500 was published in 1994. It was about 18 pages of standard material, and the rest of it, about a quarter-inch thick, was the reference guide with just background information on it. The second edition in 1999, still about 18 pages of the standard, but about a half-inch of reference material. The third edition came out in 2006, but this now is about 88 pages in the standard, and the book's about an inch thick by this point. But something really significant happened, and that is this ANSI certification here, American National Standards Institute. You'll see that all over the place. You'll see it on safety goggles and all sorts of things. ANSI doesn't necessarily care what's in the book. They care how the book was put together, that it's not being promoted to push one certain product or chemical or process, that everybody had a say. There's a consensus writing body. They put it together. The book through ANSI goes out through peer review. All those tens of thousands of people who write it and say, well, I think 13.2.7 is incorrect because of this. It should be changed to that. Tens of thousands of those comments need to be answered and addressed, and they'll say as a consensus body, we agree with that. We're going to make the change. We disagree, and here's why we're not going to make the change, or we're going to kick that down the road to the next consensus body. So that was significant. If there's ever litigation or situations like that, this is the book. This is what's going to wind up being cited in that type of a situation, which we all want to avoid, certainly. The question's been asked, when water damage hits the structure, how long does it take for the attorneys to start to grow? And we don't know the exact time frame on that. So one of the things that I realized in doing webinars is that with a live class, you can kind of get some feedback on my really bad jokes. And I thought that was more difficult to connect on a webinar, but now I realize I can't see the look of horror on your face. So it's actually probably better. The fourth edition came out in November of 2015, so it's still fairly new, some significant changes, still about the same size. It is what we call kind of a living document. We are currently doing the fifth edition and well down the road on making some changes that are critical. As new science emerges, new techniques emerge, things that we learn, then we continue to continually review and process this. So that's what the S500 is and why it's such an important document in our industry. There's some language you need to be aware of within the S500. Shall, should, and recommend or recommended. Shall says this has to happen. It's mandatory. It's either a natural law or a federal requirement, regulation, law, whatever it is. When I think of shall, I think about if I jump up in the air, I shall come back down to the ground because of the law of gravity. There's nothing I can do about it. It can happen every time. That's a shall. It has to happen. There's no getting around it. Should says that this is part of the standard of care and it needs to be followed. It's critical, but there are times where there can be limited times, rare times, where there can be a deviation to the standard. And so you may look at it and say, I did a job, we had some mold on the inside of a wall, a very small amount of mold. The S520 said the drywall has to come out. There was a large computer and phone bank on the other side of the wall. And so on a deviation on that one, we cleaned it up and did some encapsulation. Normally, that's not the right way to go, but in this situation, economically, it made the most sense. So I want to be cautious about that. It should be very rare. Everyone involved in the process needs to be aware of a deviation. And a deviation is not a license to do something wrong. It means there's another way to get there, kind of like a detour in traffic, not a road closed sign. Recommended says this is something we advise or suggest. It's not part of the standard of care, but important enough that we recommend that this process be followed. There's some other language just to be aware of as well. Shall, should, recommend, and then there's may and there's can. So may says the permission is given within the standard. Not part of the standard of care, but yes, you may do that. That's acceptable. And can says it's possible or permissible or could be that way. So just some language that we look at in every word, every bit of the standard of care when we get involved. with various situations. As I mentioned, with the 3rd edition and the 4th edition, there were some critical changes. As we go through the presentation today, I'll talk about the various things that are on the presentation and then bring in some of those key changes and the impact that they've had. So the first up we're going to talk about is categories of water damage. Categories of water damage refers to the range of contamination. How icky is it? What's going on there? This has to do with where the water came from, its source, and the things that it's touched after it came out of the faucet or a toilet overflow or whatever it might be. Rainwater coming in from the outside, leaking scupper, whatever might have brought the water into the built environment, and then what it goes through once it gets in there. Time and temperature, when it comes to water damage, is our absolute enemy. The longer it sits, the worse it gets. The warmer it is, you really think about it like anything else. You don't leave a chicken salad sandwich on the counter and then eat it the next day for lunch. You put it in the fridge because if it's cooler, then it's going to inhibit microbial growth. And same with the water damage. You've got a warm environment and water, you're going to have fungal and microbial bacterial growth that's going to take place much quicker than ordinarily. So those are critical. And you'll notice here in the bottom, it talks about how time and temperature can affect water changing its category. A category can change because the longer it stays there, the more things will start to grow. And so we'll talk about that a little bit here in a moment. Primarily what we're concerned, well, if you look at this graphic, the category has to do with where did it come from, our source, how long it's been sitting there, how warm it was while it's been sitting there, and are there other pre-existing situations that would lead to microbial growth or contamination, which we'll get to. Primarily our biggest concern is the classifications of things within our water and a water damage loss would be fungi or fungi, bacteria, and viruses. Basically, fungi is an airborne pathogen. It can make you sick, certain types with certain people. It's an allergen, and it primarily works its way through the air. That's how it gets around. It's so light and so tiny that it can just float through the air. A tiniest bit of airflow will move it from one place to the other. Bacteria and viruses are primarily waterborne pathogens. Their mode of transport is through the water, and that's how they get around. And so we'll talk more about why that's critical, that we kind of leave those intact where they are in a few minutes. Oftentimes, you may have heard about where people say, oh, it's clean or clear water, it is gray water, or it's black water. We don't like to use those terms anymore because it gives you a vision of what the water should look like. If it doesn't look dirty and gunky and icky, then it's probably clean or clear water. And you can have just crystal clear looking water that actually is very, very contaminated. It can have all sorts of bad things in there that can make you sick all the way up to death. And so for that reason, they've gone in the S500 with the terms Category 1, Category 2, and Category 3. Progressive terms for the level of contamination or potential contamination in the water. In addition to that, there is a situation that used to be called special situations. Now they've rephrased it as regulated, hazardous materials, and mold. And if those are in place in a job, that supersedes Category 1, 2, and 3 until it's dealt with. And we'll talk more about that here in just a few moments. So as we go through, talk first about Category 1. Category 1 is from a sanitary source. It's clean water. It's not going to make you sick. If you get it in your mouth, in your eyes, on your skin, it's not a health concern. It would come from a broken water supply line. It could be a supply line to a sink or an ice maker or a dishwasher or a coffee maker or wherever it's going to. It could be a tub or a sink overflow where there's no contaminant. So if you're cleaning something in the tub or sink, if you're filling up a tub with Mr. Bubble, then all bets are off. But otherwise, if you just fill it up and it overflows and there's no contamination in there, that'd be a Category 1. Melting snow or ice or falling rainwater. Now that's initially as it's melting or the rainwater's falling in before it would touch any other surfaces, which may or may not impact its category. A broken toilet tank is technically part of the supply system. So if there's no little Mr. Tidy Bowl or cleansing tablet in there, that would also be a Category 1. Now, if you open the tank and there's some mold slime and stuff like that, then that changes it as well. But out of the chute, broken toilet tank would be a Category 1. This would require the basic level of personal protective equipment, also known as PPE. Splash goggles, nitrile or latex gloves, just something to protect you from getting the water that's on you as you're working in that environment. Category 2. Category, by definition, Category 2 is water that contains significant contamination. A lot of times in our industry, it seems like people say, well, Category 1 is We know that's the clean stuff, and we're going to get to category 3 in a minute, but we all know that's really nasty. And category 2 is just kind of there. It's not. It has significant contamination. It has the potential to make you discomforted or sick. Things such as discharge or overflow from a dishwasher or washing machine. You've got whatever you're trying to clean, the food, the soil that you're cleaning off the dishes, off the clothes, and then you've got the detergents that you're using to clean those off. And so if you've got a discharge or overflow from one of those, you're going to have really just a microbial soup of things that can grow. It's a great nutrient source for microbes to grow with the water and with the time. An overflow from the toilet bowl with some urine but no fecal matter. So someone urinates in the toilet, they flush the toilet, the flapper valve comes down a little bit sideways, and it just runs from the tank through the bowl all day long and dilutes out the urine. That would be a category 2. Still some significant contamination potential, but with no fecal matter, it's in the category 2. Broken aquariums. Now, I get a lot of questions on broken aquariums because really, if you think about it, that's just disgusting. You've got, well, you know what's going on inside of an aquarium. That is the fish's toilet. And there is all sorts of bacteria. Yes, it's got its own filtration system. It's still pretty nasty. And a lot of people will say it seems that an aquarium would be a category 3. And I always like to remind them that a category 2 has significant contamination, such as an aquarium. So there's kind of a big range on a category 2, where you've got maybe a dishwasher discharge might be just at the tail end of it, the beginning of a category 2, and an aquarium would be certainly pushing toward the back end, pushing towards a 3. But that's what you're up against on those. And you're going to need some also seepage from hydrostatic pressure with some capillary action differentials where you've got moisture coming through CMUs or a slab, something like that would also have some contamination. Now, concrete typically has a fairly high alkalinity content, which is an antimicrobial, but all the dirt and soil. You'll ask, well, kind of the question goes out is, can mold grow on ceramic tile or glass? And we'll talk about mold in a little bit, not extensively in this today, and the answer is no, it can't. But we see it in showers, we see it in areas. Well, that's because it's growing what we call the biofilm, the soap scum and the skin cells and things like that accumulate on those surfaces that allows it to grow. And so the same thing with concrete, where you may not grow very well right on the concrete, but certainly the contamination, the soils, the things like that on the concrete can be a way for it to grow. This would require increased PPE, potentially an N95 respirator, a half-face respirator, and some more caution in the things that you're working on. Okay, off to the fun stuff. Category 3. This is grossly contaminated environments. It can contain pathogenic and toxigenic and other harmful, nasty, icky, gross, disgusting stuff. I'm paraphrasing slightly on that. Sewage, obviously. The things that are within sewage is vile and gross and disgusting. Wasteline backflows that originate from beyond the trap. And so if you have a toilet that overflows and went beyond the P-trap and mixed into the drain system and it comes back, then it may not be full of sewage, but you'll notice there's just waste line. It used to say, and we'll get to this in a little bit, toilet backflows. But if you have water that goes beyond the trap into the drain and then comes back up through the tub or the shower or the sink, once it's mixed beyond the trap down with the other water that would have come from a toilet, etc., it is a category 3 water, regardless of where it exhibits. All forms of flooding from seawater and rising water from rivers or streams. Well, wait a second. We just said an aquarium is a category 2, and now we're saying a really big aquarium is a category 3. Well, a little more to it than that. Yes, if you've got rivers and streams and seawater, you've got fish and bacteria and all sorts of nasty things going on in there. But in addition to that, when it overflows and moves across the dirt and the ground surfaces, it's picking up pesticides and fertilizers and animal fecal matter and all sorts of other stuff that gets mixed in. And usually by the time the river overflows, the sewage system for the community is overwhelmed, and that also is mixing into it. So a river water flood might not smell or look as bad as a raw sewage, but probably worse because it has all that and more. And at this point, you are in a full level of personal protective equipment. Full face respirator. It could be a half face. I prefer a full face. Tyvek suit. Well, and if you're in sewage environment where it's wet, you'll want a Ceranex coated suit for some level of non-penetration of moisture through the bodysuit. Gloves, taped off gloves, with leather gloves on top of that if you're doing any sort of demolition that could puncture them. But just really, you need to protect yourself. It's all about, we know that when we go into these types of situations, we know the nasty stuff is there. We just simply don't want to allow it to get into us. We want to protect ourselves. And so that's what we're trying to always take care of. So here's my quick disclaimer. Really icky, gross, disgusting pictures coming up next. Really nice lady called us. Oh my gosh, how soon can you be here? And so I realized so these are kind of nasty pictures. So if you have a queasy stomach, I'll let you know when we're done with the pictures. But when she called and said, how soon can you get here? Oh my gosh, this is terrible. And we pulled up and went to her basement. Well, very quickly, the line, the main sewer line in front of her house backed up. And so everything that came down, and the nice home at the bottom of the hill, and the plumber didn't want to put in a backflow preventer valve, that's $170. So everything coming down the street in the main line from people who flushed the toilet, ran the sink or dishwasher, took a shower, wound up in her basement. So when we showed up, this is what was going on. Now, if that's from your family, that's just beyond disgusting, but this is a horrible way to get to know the neighbors. And it was literally just shooting out of her toilet. The whole neighborhood, miles up the street, showed up in her basement. If someone says, it came out of the tub, I don't think that's a Category 3 water situation, I would argue with that. This is definitely Category 3 water coming out of the tub. This is flowing out of the back door to the backyard. Now, I will say, her garden that year was spectacular. No zucchini for me. Thank you so much. Anyhow, bad stuff. Once they finally drained the line, cleaned the line up front, and the water's able to start to drain back out, this was the residue left in the tub. Now, it doesn't always look like this, but these kind of microbes and residue is going to be there. You need to be in proper personal protective equipment and protect yourself. On a hurricane, wind-driven rain from hurricanes and tropical storms or other weather-related events is a Category 3 loss. So all the silt, all the gunk, all the ick that's coming in from that can really make someone, again, sick all the way up to death. So a couple of quick changes. Now, there's a lot of words on these slides. I just want to focus on the red. So Category 1, as we talked about, it used to say in 2006, once clean water leaves the exit point, it might not remain clean. It contacts surfaces and materials. What they're trying to say there is you've got to look at what it flows to. What a lot of people interpret that was there's really no Category 1 water because once it hits the carpet, it's now contaminated. So there's a clarification in the 2015 edition, if you look over the right side of the slide, where it's going to tell us that water that flows into an uncontaminated building doesn't constitute an immediate change in the category. It's still a Category 1. Now, yes, if it goes into a contaminated building, it's instantly going to be a 2 or a 3, depending on the level of contamination. So these are just some of the examples of the changes that are occurring in these editions as they go forward. 2006 to 2015, Category 2, no change in the language. That all still stays the same. A couple of changes when it comes to Category 3. Ground surface water used to be in the 2006 edition. That was removed in 2015, kind of a big deal. I think what happened there was you'd have a hose bib that leaked right next to a foundation, dropped into a basement, got 4 or 5 feet of water wet, and people said, well, groundwater, Category 3, tear out all the carpet. And so they're saying you got to use some prudence on this. You got to look at this a little bit more clear. So that was taken out. All that doesn't mean ground surface water is not a Category 3. It simply means it's not automatically a Category 3. And so in that situation, if it comes across the parking lot and a lot of rain and everything comes in, it's going to be a Category 3. They did, as I mentioned, change it from toilets backflow to waistline backflow, and then special situations is now referred to as regulated hazardous materials and mold. 2015 makes it very clear, if the determination is Category 1, that you can proceed on the job without engineering or contamination controls. But it's always about, as it says in the second bullet, remediation first, and then drying. We've got to do decontamination first, and then you don't want to bring a bunch of air movers in and start blowing contamination around. So if you've got waterborne contaminants, viruses and bacteria, and you come in with a shop vac, that does not have a HEPA filter. You're literally going to take something that's a waterborne pathogen and aerosolize it and make it an airborne pathogen. So we want to be, or even with air movers, you just extract the water, suck up the water, and throw some big fans, air movers on there. You can bring those contaminants up into the air, and that's going to be a problem. Regulated hazardous materials and mold. So if the water has mercury that came out of an old CRT monitor, or PCBs, polychlorinated biphenyls that came from a ballast on a light fixture, or some asbestos that came in from drywall texture, that is not a Category 3. That's regulated. That has to bring, you'll notice at the bottom, an indoor environmental professional, an IEP. That is a generic term for someone who is qualified, maybe industrial hygienist, a certified industrial hygienist, who is qualified to make determinations on air and water contamination levels and quality. So once this is taken care of by the person that's qualified to do that, then you determine category and dry up the building. But this always takes precedent. Mold a lot of times will happen in conjunction with the job, but it still has to be dealt with separately. If I have category 2 and 3, by virtue of the standard, carpet pad is removed and discarded. Lined ductboard or external insulation on my HVAC systems is discarded. Wall insulation is discarded. Particle board or medium density fiberboard materials are discarded. Multi-layer floor systems, if I have a laminate or parquet or sheet vinyl, or hardwood, if water gets under those floors, they cannot be decontaminated, so they need to be removed so they can be cleaned underneath. If it's a category 3, it goes on further. Gypsum wallboard must be removed on a category 3. Ceiling tiles, which are probably damaged anyhow physically, wall insulation, soundboard, wallpaper, carpet, and pad. This is not an exhaustive list, but gives you some idea of the materials that must be removed. So carpet on a category 3 is now dumpster material. It cannot be saved. The category of water, I'm not going to read this whole slide, but it's simply saying that the category may deteriorate if it gets in contact with dirty stuff in the, soil contaminants in the building, if it's been there for a long time, if they've had other water losses that weren't properly taken care of, general housekeeping issues, if it's a veterinary clinic, stuff like that, it's never going to be clean. And again, time and temperature will elevate that. So what category would this be? Well, the answer is we simply don't know. Is this a supply line to a coffee maker an hour ago? Is this a toilet overflow 2 weeks ago? You cannot look at a loss and say, oh, this is a category 1, 2, or 3. You must do some investigation, find out where the water came from, what it's flowed through, and how long it's been sitting there. Antimicrobials or biocides, such an important part of what we do to maintain health and safety in a facility, but also have to be careful because they can cause health issues. They are a bio, which means life, side, which means kill. So virtually something that kills life. Now with the life we're trying to kill is microbial life, little tiny stuff, but still, that's what we want to be cautious of. In the 2006 version, it said, hey, if it's a spot that's slow or difficult, then you might put on biocide to keep things from growing. They clarified that in 2015. It said, if it's a category 1 loss, we're not worried about contamination. It's still a category 1. Generally, you don't need to put on an antimicrobial. Just get it dry. If you get it dry, things aren't going to grow. You get lots of airflow on there. Microbes like stagnant air. They're not going to grow well once you get the air movers in place. So just kind of be aware of that. A couple other things on biocides or antimicrobials. Must be in gloves and respiratory protection at a minimum to apply. And it's against the law to use these inconsistent with labels. Now, most of the time, I think where that happens in our industry is it'll say on the label, if it's not RTU or ready to use, that this has to be in a ratio of 2 ounces per gallon or whatever it might be, and people don't have measuring cups, and so they measure it out using the glug-glug method. Glug-glug-glug-glug, that's about right, and more is always better. So you've got to measure it, document where it was used and what it was. People and animals must be out of the premises or at least the immediate area while it's being applied. Written authorization, communicate, no surprises from the odor, the effect, what it might be, and the SDS sheet, safety data sheet provided to the critical people who are making those decisions of when and where to apply an antimicrobial. This jumps us over to engineering controls. In 2016, it said on this top slide, I don't have it in red, contaminants should not be allowed to spread into areas known or believed to be uncontaminated. It goes on in 2015 to clarify and say, in these grossly contaminated environments for stores, this is a shall, implement procedures to minimize the spread of contaminants. So contamination, engineering controls such as containments or isolation chambers, air filtration devices, and various work practices to make sure that if we have a contaminant in one area, category 2 or 3 water, even if it's got mold or whatever, that it doesn't contaminate somewhere else. We don't want to ever fix one problem and in so doing create or cause a problem somewhere else. So plastic is a great way, if it's properly sealed off, to control contaminants from moving to another area. An air filtration device, these are AFD is what it's referred to in the S500. Oftentimes these are called a scrubber or a negative air machine or a NAM, N-A-M. These have a pre-filter, which you can see right here. That picks up the big stuff. If you're tearing out drywall, there's a lot of dust. I want to catch it in my $8 to $12 pre-filter. Some of the smaller contaminants we caught in my secondary filter. And so, over here, sorry about that. My secondary filter, that's going to be about a $15 to $20 filter. And then my really fine, tiny stuff is what's going to go into my HEPA filter, my $150 to $300 filter. That's for my asbestos. If you're doing asbestos work, not the topic of today, but mold, things like that. And so you also have secondary filters here that are made of carbon activated, or charcoal. That's going to pick up odors if you're doing sewage work or firework, things like that, smoke issues. And then you've got your HEPA filter, which is it gets everything down to 0.3 microns. A sheet of paper is about 200 microns thick. A micron is 25 thousandths of an inch, and this is picking up 99.97% of a third of 1 micron. So it's really getting the small stuff going through. You've got to make sure your equipment's working properly, that everything's seated in properly on your filters. But a critical thing of what we do. On category 2 or 3, you need to have containments and isolation barriers from other uncontaminated areas, and should be utilizing air filtration devices to pick up those dust, debris, and contaminants as they're being stirred up into the environment. It does talk about this in the S500. Basically, air-moving devices are going to aerosolize soils and particulates, and especially as water evaporates. You think about picking up if you've got crumbs on the floor and you've got a paper towel to pick them up, well, if you get that paper towel damp, they stick to the paper towel. They don't stick well to a dry paper towel. Well, this happens to us in reverse, especially with demolition. People are tearing out wet drywall, wet particle board. It's sticky, it's thick, it's wet, it's clumpy. But then it starts to dry out, and it no longer adheres, and it becomes up in the air. And so because of that, where preliminary cleaning cannot sufficiently remove soil particles, you can install 1 or more air filtration devices. And it's a good idea to control that environment. And even just from a standpoint of keeping your people happy, they can tell you're doing all that you can. It does work, but you also want to show that you're doing a good job of that. We also use AFDs, what's called negative air. So for example, if I'm in a master bathroom and there's sewage, category 3 water, if I just start ripping up, and maybe there's some mold in there too, if I start ripping up affected particle board and drywall, those microbial particles are so small they can move through plate covers, under wall plate, into adjoining areas, especially if you turn on a fan in the hall bath. So if I take my ducting on my air filtration device and blow the air outside, air has to replace that air from somewhere, and will come in from the surrounding rooms. And the microbes have no ability to, if you will, swim against that flow. And so negative air creates no cross-contamination, and that's its purpose. Be careful you don't draw in from another contaminated area, like a crawl space. Be careful you don't backdraft gases from a furnace or a water heater. But negative air is a very important part of what we do. All right, jumping forward to classes of water intrusion. So it says that we need to estimate the humidity control that's needed. And so how dense are my materials? What type of materials? How wet are they? How much material? How many? There's a lot of drywall in there. There's a lot of carpet that I'm trying to save. How wet are they? And again, the density of the structure and the materials. And so is it hardwood floor? Is it drywall? Is it 2 layers of drywall? Is it, what am I up against? Kind of a quick way to think about this is you go to your bathroom and the tub is full, and you try and drain it and it won't drain because it's clogged. And then you realize that the tub is also, the faucet's leaking. So there's 20 gallons of water coming a day into the tub, and the plumber can't get there for 2 or 3 days. Well, if you've got 20 gallons a day coming in and you don't do anything about it, it's going to overflow the tub and affect the floors and the walls and cause damage. You'd have to get a bucket, a 5-gallon bucket, and 4 times scoop that out. So if you scoop 20 gallons a day out, then the water coming in won't overflow, and by the time the plumber gets there, no damage. Think about that now, where I've got wet carpet, wet drywall, wet flooring, plywood, particle board, dug for studs, whatever it might be, and I bring in air movers and start to evaporate that moisture out of my materials. Well, even though that moisture is now invisible, it's not a liquid, it's still, if I bring 20 gallons of water out of my materials into the air, then I have to bring 20 gallons out of my air. That's what my dehumidification does, and that's what class is. So the faster it absorbs, the faster it's going to release. Carpet absorbs quickly, dries quickly. Drywall absorbs slower, and dries slower. Hardwood, concrete absorbs very slowly and releases very slowly. So just again, depending on the type of material, is going to refer to what we call the evaporation load, how much potential moisture. And we use this to figure out how much equipment we need. So I'm going to start to kind of move it up here a little bit. Slow enough if you need to. This is pretty straightforward. Class 1 says, if in my overall drying environment, we call it drying chamber, if walls, floors, and ceiling, I take the total square footage, I divide that by the area that's actually wet. And if it's less than 5% of my overall area is wet, that's a class 1 loss. Pretty straightforward. Class 2 loss says, If the wet materials are between 5 and 40% of the overall area, that's a class 2 loss. I'm now going to have more evaporation taking place, and I'm going to need more dehumidification. A class 3 loss, exactly. Now, there's only a portion of what it is, but this is the critical part. A class 3 says, if my wet materials are greater than about 40% of the combined surfaces, now I've got a lot more evaporation taking place, and I need a lot more dehumidification. And then class 4 jumps gears a little bit, and it says, this is bound water. So where I've got wet hardwood or plaster, if I've got gym floors, complex built assemblies, multiple layers of drywall, plaster, brick, things like that, it's not a percentage, it's the type of material and how difficult it will be to try and dry that, because it takes a long time to absorb in and a long time to dry back out. So it used to say in 2006 for a class 1, if it's only part of the room, and now it's 5%. In class 2, it said if it's the whole room and maybe it's soaked up the walls 24 inches, and now it says it's between 5 and 40%. And class 3 used to say it came from above, everything's wet, and now it's above 40%. Class 4 used to say it's a specialty drying situation, and now it refers to it as deeply held or bound water. So it kind of gives you an idea of what that is. We need to set drying goals and dry standards. Our dry standard says what was an unaffected material. If my plywood is 11.2% moisture content, I need to set a goal based on that. That becomes my dry standard. If the entire structure, all the plywood subfloor is wet, my dry standard can be based on historical data. I know that in this area, during the fall months, that my plywood's going to be between 9 and 11%. I'm choosing 10% as my standard. But it's based on the dry or unaffected material, and I'm supposed to set my goal to dry it back down to that. So during the initial response, I should set my dry standard and goals. Hardwood should be within 4 percentage points. Finished wall material, if it needs replacement, has to be dry enough that I'm not going to get mold on the drywall. It used to say 16%. Now it just says get it dry enough. We have documentation that at least should be below 18%. And for all materials, it should be below 10%. So if my unaffected area is 9%, I need to dry the affected area down to 9.9% if I'm using the moisture content scale. Moisture meters, that's what tells us what's wet and how wet. Allows us to quantify it. They're used to determine which materials are affected and how much moisture is in those materials by either moisture percentage or moisture level. It helps us set our dry standard and dry goal, and they can be relative or moisture content. We'll talk about that here in just a moment as we move on. So how do they work? Well, with what's called a penetrating or pin type or invasive meter, you poke it into the material and there's electrical resistance between the two probes. I always get a funny look when I ask this question, but if you've ever put a 9-volt battery on your tongue, if it's a good battery, you'll get a little zap, and if it's not, you won't get anything because it completes the circuit. I'll just say I have 3 older brothers. I didn't choose all my own life experiences. That's why I'm putting 9-volt batteries on my tongue. So you poke it into the material, and it reads back and forth and gives you a percentage of the moisture content by weight of that piece of material. And non-pin, non-invasive, non-penetrating meter works through capacitance. It'll, in essence, sends out a radio signal, if you will, and reads the more moisture. So this tells me what's going on. The penetrating at any point in the material has a moisture content. This is just, it's like a gas gauge. A quarter tank is empty, E is empty, F is full, where am I at? This just says, hey, depending on the meter, it's the scale of 1 to 100, 0 to 100, 0 to 300, 0 to 1,000. And the unaffected area is 37, and the affected area is 268. And it simply says 37 in this instance, it's all it's doing is comparing the same material to itself and what's wet and what isn't wet. So they're great meters. They're great because we don't have to poke holes and stuff. Initially, like vinyl floors and vinyl wallpaper and ceramic tile. I'll jump back to that here in just a minute. We also have a thermal hygrometer. It tells us the temperature, thermo, and the relative humidity or hygro. Using that information, I can calculate all sorts of other information about what's happening in the air, what's called my psychrometric conditions, and that allows me to know if my conditions for my drying environment are good. Jumping back to, I have this slide out of order, I apologize. Jumping back to my non-penetrating meter, it will not read through a gap. So if I have dry wood paneling and wet gypsum board, and there's an air gap in between, it will not tell me that it's wet inside. It won't go through a gap. If I have wet insulation right against the sheetrock, yes. If I have wet insulation, or I'm sorry, if I have dry insulation with a foil back, that'll give me a false reading. It'll see that metal that's conductive, and it will think that it's wet in there. If I have wet insulation and a gap and dry sheetrock, gypsum board, it won't tell me that, so it will not go through an air gap. I can get a false reading on any meter if I hit metal studs or corner bead like we have right here, air gaps, HVAC, ducting, or plumbing. Anything that will not allow the electrical impedance, or anything that will tell that, that will conduct electricity that's not water. So we've got to be careful in using our meters, but they are critical. We also use infrared cameras. Very important part of what we do. As moisture evaporates from a surface, it cools that surface off. Infrared camera does not say it's wet or dry. It simply says that surface is cooler. Potentially could be evaporation. Go check it with your meter. So we always validate with the meter. Infrared cameras are great on a large loss or someplace it's hard to get to identify suspect materials. Always verify with the meter. Here, for example, it's colder here only because it's an air conditioner. And so we have to know how to do it, how to use it properly and not be, could be missing insulation. There's a lot of things that could be indicating it's cooler that's not necessarily because it's wet, but it is a great and important tool. How much dehumidification? So it tells us in 2006 that on the first part of the job, when all the moisture is coming out of my materials, I'm going to get a spike, may last a couple hours. They realize now that that could last a day or longer. And so sometimes we just have stabilization while we are waiting to do the demolition, while we're waiting for an asbestos test, whatever it might be. We've got to dehumidify so that moisture comes up in the air and has nowhere to go. It's going to go into books and documents and paintings, and it's going to cause what we call secondary damage. So this is the chart that we use. I'm not going to go into it very extensively. We say, what's the class of loss or the potential rate of evaporation, my evaporation load, what kind of a dehumidifier, conventional or low-grain refrigerant, and then here's some factors I use. And I simply say, how many cubic feet am I processing through my dehumidifier? I divide it by my class factor for a refrigerant dehumidifier, and that tells me how many pints rated at the AHAM's Association of Home Appliance Manufacturers. If I'm using a Deskin, it's on off air changes per hour, how many cubic feet of air. So I take my total cubic feet multiplied by how many times I need to process or change that air. That gives me the total cubic feet. I divide by 60 minutes in an hour, and that's how many cubic feet of minute or CFM of air I need to process. There are some changes between the two. In the 2006 edition, it was different amounts for Class 3 and Class 4, and now it's the same for 3 and 4 for different reasons. Class 3, a lot of evaporation taking place. Class 4, not a lot of evaporation taking place, but I need to lower what's called my vapor pressure differential to pull those materials, the moisture out of those materials. Air mover replacement. How many air movers do we need? In 2006, it said you get one for every 10 to 16 linear feet of wall. It's always a range, a high and a low. So they say, okay, you measure the wall, you divide by 10, you divide by 16, that's how many you get. But that was too complicated. So in 2015, they wanted to clean that up a little bit. It tells us that we have to have continuous airflow on all of our wet materials, all of our surfaces, floors, walls, ceiling, framing, whatever's wet. You can't dry it out without airflow. I've got to get adequate circulation throughout the drying environment. Direct airflow across the open surfaces, and look for furniture and fixtures. So here's how they've simplified it. It's calculated by the room. I put one air mover in the room. Then for every 50 to 70 square feet of affected floor, I get another one for that room. And that'll dry also at 2 feet up the walls. So for every 100 to 150 square feet of wet sheetrock, walls and ceilings above 2 feet, I get another air mover. And then if I have an offset that's greater than 18 inches, I get another air mover. And if I calculate and it's a fraction, I move. See how much easier this is? All right, a little sarcastic, but it works. And so it's always a range. What they're trying to say is, let's say that if you say I bought a gallon of paint, and that will do between 200 and 300 square feet. This is saying one air mover in some situations might do 50 square feet and one might do 70. So I bring in one air mover, the type of air mover, the conditions of the room, that might do 50 square feet, where the other one does 70 square feet. So for example, if I have 750 square feet of wet floor, I divide by 70, which is 10.7, round up to 11. I divide by 50, which is 15. I get between 11 and 15, but because it's a room, I add one air mover. In that room, on 750 square feet of wet floor, I would get between 12 and 16 air movers, and the restorer has to figure out how to place those and how many they actually need. And so that's how it works. If, however, I have a room that the water's only come out less than 2 feet and or less than 2 feet up the wall, I don't do square footage. It goes back to a linear method. I take the total linear feet of wet material, I divide by 14, round up, and that's how many air movers I get. Last thing I want to touch on that's so critical is asbestos. A lot of people think, oh yeah, asbestos was banned, and it was from 73 to 89. What a lot of people don't know is that was vacated or overturned in 91. So anything that was being used for asbestos, or uses of asbestos at that time, were re-permitted. And they said, yes, you can go ahead and do that. And so then you've got asbestos being mined in Canada, coming in from other countries, and it is being used today. We find projects that are a year-old commercial projects that have either been remodeled a year ago or built a year ago that are full of asbestos. It's not as common as the 40s and 50s and 60s and 70s, but it's still there. In the S500, it does talk about both fight the OSHA general duty clause. Hey, you have to provide a safe place for your employees with no hazards. Well, asbestos causes cancer. We know that. Both editions state that it's the restore's responsibility if there's asbestos-containing materials where it's presumed that might be cut or drilled into to be aware of that. The standard now says asbestos-containing materials might be found in buildings of any age. So if you're in, I can't remember all the states, I know Colorado and Massachusetts and others say if you're cutting drywall, we don't care how old it is. The building could have been built yesterday. You may not disturb drywall. Don't take off baseboard, drill holes, cut out sheetrock without an asbestos test, a current asbestos test on those materials. Okay, Chris and Billy, that is what I have. So I want to leave some time for questions. I hope we got enough time for that. This is the part of this. So what have we got?
Well, Darren, this has been really a lot of great information. Can you go back to the last point, asbestos? Because I think there's a misunderstanding that during that period of time, 1973, did you say it was 91? That asbestos was being used?
Yeah, the asbestos has been used for years and years for a lot of different things. It used to be used in cigarette filters and gas masks, all sorts of stuff. But it was used. Asbestos is amazing. Friction resistant, fireproof, heat resistant. It's a great binding agent. If it didn't kill people, it'd be like the perfect product. And so once they realized the negative health effects, starting in 73 through 89, there was several bans that went into place. But those, there's a lot of money in asbestos, and there was a lot of lawsuits. And in 1991, those were overturned. So it is completely legal, albeit incredibly stupid, but completely legal to apply drywall texture with asbestos in it. Now, it won't say like it used to, hey, contains asbestos. It'll say mineral additive, binding agent, secret ingredient, chrysotile. But right now, you could probably go to Home Depot or Lowe's and buy a joint compound or texture material that actually contains asbestos. And so we have to test.
And
go ahead.
Go ahead. Is there a percentage that's allowable? Because we're talking drywalls, the mastic, in the flooring, in the carpets, in the ceiling tiles. Is there any percentage that's allowable?
So I'm not. I have been a HERA certified, but I want to make sure I go outside my area of expertise. The way we interpret the federal regulations is anything that's 1988 or older for mastic and vinyl and those types of things needs to be tested. For 89 and newer, we're talking about drywall texture and compound. You'd have to talk to an asbestos person. My understanding is that if it has asbestos, it's asbestos, and you need to be licensed to deal with that. So I heard a lot of people say, well, if it's under 16 linear feet, well, that's just how if you're going to NESHAPs and OSHA and EPA and how you notify them it's going to come out by a licensed person. I hear people say, well, the way they take out asbestos is get it wet, and it's already wet. Well, there's one step they're forgetting. You become a licensed asbestos abatement contractor, then you get it wet. So, yeah, my understanding is there's no minor maintenance rule or percentage. If there's asbestos, there's asbestos. Now, there's courses you can take that you can do a minimal amount once you've taken that course and been certified in it. But if you're not an asbestos person, my understanding is 0%, 0 linear feet, 0 square feet is the safe place to be.
Well, very interesting. The best thing is to also work with your respective risk management departments on your campuses. The other question that comes up, we have a number of aging infrastructures on our buildings throughout our United States, the 50 to 60 year range with these buildings. And sometimes you are getting the mold issues in there, depending on what part of the country, even out here in the dry Southwest. What are the official mold standards for testing and cleanup, or is there?
Yes, there is the S520, which is it's based on ACGIH. It's based on the New York State guidelines. It's based on EPA for buildings, commercial buildings and schools. But the S520 standard is again, it has the ANSI certification, and it is the industry standard. It talks about how like the New York City guidelines that has less than 10 square feet of visible mold, between 10 and 30, I think, and above 100. In the S520, mold is mold. If there's visible mold, that's called a condition 3. Condition 2 is settled spores, and condition 1 is a normal environment. And so that would be the documentation to go through of proper dealing with and remediation for microbial growth, for mold, not microbial, for mold.
And would that guideline be used to a portion? And we got great questions coming in. Dave Meharry, good to have you on the line, Dave. We appreciate you. Dave Reiber, University of Arizona, we appreciate you dialing in along with hundreds of others. But back to the mold question that's coming up, is that the guideline for cleanup, or does that also include the guideline for testing?
It does not include the guideline for testing. There is a new standard that they're developing on that right now that's not in play yet. And so the guideline for testing I hate to say it, it's so vague right now, because really a lot of times they say, well, we're going to compare the inside sample on a volumetric air sample to an outside sample. And if it's a rainy day, if it's spring, if it's fall, if it's snowing, if it's windy, you can have a huge impact that's going to change that. We don't have permissible threshold limits like we do for arsenic and asbestos and ozone for mold, because there's so many species. It's an allergen. It affects everybody differently. So you will have some industrial hygienists who will say, hey, in our area, we've noticed that Penicillium aspergillus, if it's below about 3,000, we're calling that good. But there's no national guidelines on permissible threshold limits or TLDs.
Do you see any at this time? And I know there's also been conversations with ASHRAE regarding this specific topic and developing something a little more specific. Do you see anything in the horizon from your experience?
You know, you've got several states. California passed laws years ago saying they were going to have some requirements, and then it got caught up in funding. You know, you've got Virginia that was in and out. You've got Texas and Florida. To get all the states to agree, if it does happen, I think it's a ways down the road. But I don't have any insight on that, but that'd be my guess.
Okay. Another question that's come in, Darren, is preventing the mold, about the dry out procedure. When you have a number of our universities have museums, some of these museums have priceless artwork in there where there may have been a catastrophic failure on a sewer line, a major domestic line. The dry out process for cork floors, for libraries, books, artwork. Can you comment on that?
So there's a couple of different, I'm not going to get too deep into cork floors because there's so many different variations of what they are and how they're installed and what they're installed over. They're fairly porous. They can be dried depending on the contamination level on a category 1 if there's not physical damage. When you get to a library or art and things like that, there's two different things that are happening there. One is, are the material and piece themselves damaged, or are we just talking about the drying environment? So if I have books and documents that are damaged, those can be processed through what's called a sublimation chamber. In essence, it's freeze drying that are processed, and we can provide information. Actually, we can give you a great webinar on that if you want it. And there's several people in the industry who do a very good job at that, as well as we do. So I've got to control the environment if I'm drying the structure, so I don't affect the very particular relative humidity requirements and temperature requirements of the artwork and the documents. So, you know, if you've got specific artwork, then there's conservatories that can help with that. If you're talking about the environment, then yes, we have to look at it and say, I want to warm the environment up to dry my structure, but I have to make sure it's not going to cause problems with the other, you know, elements of the drying job. Am I going the right direction on what I'm saying?
That's helpful, and I think you mentioned too that there are opportunities in major libraries if you have a books and such, and a lot of that's becoming electronic, but you can go through the dry out process. If it is category 3, are those complete losses?
No, they're not, because you've got someone, you know, from a personal level, their wedding album from 50 years ago. There are books and documents that are very, you know, they might be. Well, we did a big document job where you've got bonds, bearer bonds, all the values there, and so I don't want to do a commercial, but this is really one of our specialties where we not only can freeze dry them or sublimate them, but we have the ability to run them through radiation chamber. And my mind is slipping. I can't believe I've said it 1,000 times. Gamma radiation. And so once it goes through gamma radiation, everything's dead. and then it can be HEPA vacuum and cleaned off. So depending on the value of the document, whether it's the value of what the document says or historical value, yes, there are ways to preserve and save those. They may not come back looking just the same. They may be what's called cockled. You can, if it was wet going in, now we have ways to, it's obviously more expensive, but there are ways to preserve it, rebind books and things like that. But yes, those can be saved even with Category 3 water if necessary.
Excellent. Another question has come in about the IICRC training. Can you comment on that? As our industry is seeing a large number of folks retiring, we want to now be looking ahead in succession planning, developing our leaders, our custodial staff, those who have to make sure the buildings are protected, cleaned properly. Can you discuss the benefits a little further about the IICRC training? And that's multiple, from carpet cleaning to mold restoration.
Upholstery cleaning, carpet cleaning, flooring inspector, installation. There's a lot of different certifications. Depending on what you're trying to accomplish, I'm going to focus more on water because that's my thing. But there's just, first of all, if you're not going to get certified, at least be familiar with the standard and have a copy and read it and understand what it's saying and how to do it right. But if that's something that you're doing, part of it, I just think it's beneficial to have that training and have that certification because you've gone through the process to really get the focus on what they're trying to say in that standard. And so it really is becoming much more popular. It's been there for a long time, but it is becoming more and more important in this industry or any of those industries to have that certification. And we've got this, I'm going to jump back just, again, not by way of commercial, but I'm going to put my email on here. If people have specific questions on IICRC, I am an approved IICRC instructor, and I'm very involved with the IICRC. So if you have questions on that in particular, please feel free to reach out to me and I can get you some good information on it.
And it's not a commercial. That's why we have some just great topics as this is, and folks are extremely knowledgeable like yourself. And so there are opportunities for certification. What does that look like? Is that a day of training and testing? Is it 2 days? Is it a week?
Currently, depending on the training, we have some that are 1 day, most are 2 day. The WRT is 3 day. There's one called Applied Structural Drying, which is a hands-on water class, and there's AMRT, which is Applied Microbial Remediation Technician, which is a hands-on mold and sewage class. Those are both 4 days. Well, I'm sorry, ASD is 3. There's a combined WRT ASD class that is 4 days that has to be done in a certified flood structure. So, and then there's a Scantron multiple choice test. You have to get 75% passing rate on to get the certification.
Excellent. Well, listen, we're getting close to the time, but we got time for one more question. I want to circle back to one of our first questions. And if you can comment on it again, it was about the wall boards. At what point after a flood do you need to be taking out the wall boards, not just drilling holes in it, not just drying in it? At what point should you be looking at taking those wall boards out?
So a couple of different things on that. One has to do with where the water came from, and the other has to do with how long it sat there. So if I have water that comes in from rainwater outside that came across the dirt, across the grass, across the parking lot, personally, I'm going to call that a Category 3, and the standard says that needs to come out. Whatever's been affected and touched by the water, it's topical, needs to be removed. One of the questions is, in the first 3 editions, the 1999 edition talked about this 48 hours. 2006 talked about 72 hours. Neither said that was the number. They just kind of use that as an example. The 2015 edition, all it says is time and temperature. It does not give a number. Now, we know that we can have microbes growing in